right, this is Chapter 1, Lesson 1 for Blue Math, okay, and this is rational numbers. So the first thing that we want to look at is actually this really cool graphic on this lesson. And this actually shows us some rational numbers. So if you can see, you have the real numbers, which are all of the numbers that are included inside. That's your largest group is real numbers, okay? You have rational numbers, integers, whole numbers, and natural numbers, and then irrational numbers. So irrational numbers are numbers that never repeat. A really popular example of that is pi. So pi is an irrational number. Okay, rational numbers, you could have stuff like you could have fractions. So 1/2 is a rational number. -2/3 is a rational number. So it's any number that can be written as a fraction or has a repeating decimal. It could be positive or negative. Integers are positive or negative whole numbers. So like 2, -2, -3, -596. Those are all considered integers. Whole numbers are anything from 0 and onward towards positive. So 0, 1, 2, 3, 500, whatever the case may be. They have to be positive whole numbers. Okay, and natural numbers are numbers like 1, 2, 3, 500, 1,000. They don't include 0. So natural numbers don't include 0. Okay? So the smallest group are positive whole numbers. They don't include 0. Whole numbers or positive natural numbers, they don't include 0. Whole numbers include 0 but are still positive. Integers include positive and negative, but they're still whole numbers. Okay, so there are no decimals, anything like that. Something like the square root of 4 is also considered an integer. It's also considered a whole number and a natural number because the square root of 4 simplified is 2. Okay? Rational numbers are any fractions or anything that can be written as a decimal or a fraction that repeats or terminates. Okay? So and then irrational numbers like pi, they go on forever, but they don't actually repeat. So anything like that. Okay? And then they're all technically real numbers. We're not dealing with imaginary numbers yet. They're in another sphere by themselves. Okay? Numbers that can be written as a comparison of two integers expressed as a fraction are called rational numbers. So numbers that can be written as a comparison of two integers expressed as a fraction are called rational numbers. The decimal form of a rational number is called a repeating decimal. So a repeating decimal is the decimal form of a rational number, a repeating decimal. Okay? If the repeating digit is 0, then the decimal is a terminating decimal. Okay, so if the repeating digit is 0, then the decimal is a terminating decimal. The first example I have is write each fraction or mixed number as a decimal. So the first one I have is 5/8. 5/8 means 5 divided by 8. Okay, so when I do that, I'm dividing 5. 5 goes inside. Okay, 5 goes inside. So this is what it looks like. This is a little small. 5 goes inside, 8's on the outside. All right, and I'm going to go ahead and divide it. Well, 8 can't go into 5, so I have to add a decimal. 8 can go into 50. It goes in 6 times. 6 times 8 is 48. I subtract and I get 2. I bring down a 0. 8 goes into 20 2 times. gives me 16, which is 4. Bring down a 0. 8 goes into 40. 5 times 40, 0. At this point, my decimal terminates. It stops, okay? So when I'm writing that as a decimal, I'm going to get 0.625 or 0.625, okay? Number 2 is negative 2/3. So the first thing that you want to do is actually forget the negative, okay? Just forget it. Pretend it doesn't exist for right now. Okay. So I have 1 2/3. So the first thing I want to actually do is take this and write it as a fraction, an improper fraction. Okay? 3 times 1 gives me 3, plus 2 gives me 5, so I have 5/3. Okay, now I want to do the same type of thing. Your numerator always goes on the inside, your denominator goes on the outside. So I have 5/3. Well, 3 can go into 5. It goes in ones. 1 times 3 is 3. 5 minus 3 is 2. Okay? I bring down a 0, add a decimal, bring down a 0. 3 can go into 20. 6 times. 6 times 3 gives me 18. Again, I have 2. Now, at this point, you can see that the pattern is going to stay the same, which means that this is a repeating decimal. So I get 1.6 repeated. That bar is only drawn over the 6, okay? Not drawn over 1.6, it's not drawn over 6. It's only drawn over one of the 6's, okay? And it's almost always the first or whatever is the repeating, okay? 1.6, but remember it was negative to start with, so it's going to be negative to finish with. So negative 1.6. Okay. All right, for number 3, in a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits in 530 at-bats. So the nearest 1,000, find his batting average. Okay. To find his batting average, I divide the number of hits, 175, by the number of bats, 530. So this actually wants you to enter it into a calculator. 175 divided by 530. Okay. And when you enter, you get 0.33018867992, and it'll go on for a while. Okay, it's not a repeating decimal. Okay. I want to look at the digits. It asks me for the nearest 1,000. Okay, so I'm going to go look at my digits. Here's my tenths, my hundredths, my thousandths. So this is what I want to look at. Okay. This, I want to look at the one right next to it, is a 1. Well, 1 is less than 5, so that stays the same. So I get 0.330. That was his batting average. Example 4 is write 0.45 or 45 hundredths as a fraction. So, easiest thing to do to start with. I have 2 places behind the decimal. This is my number that goes on top. It's my numerator. I put 1 in front. There were 2 places, 2 zeros. Okay, that's also how we get the terms tenths, hundredths, thousandths, hundred thousandths. Okay, that THS at the end. So 45 over 100, 45 and 100, of course, I can simplify. I can divide both of these by 5. So I get 9 over 20. I can't simplify that any further. There's nothing that goes into both 9 and 20. So 9/20 is going to be my final answer. So problem number 5 gets a little bit tricky. So let's go over that one. It says write 0.5 repeating as a fraction in simplest form. So I'm going to assign a variable to 0.5 repeating. Okay, so let's say it's n. Can be any variable that you want, completely up to you. I'm going to use n. So n equals 0.555, and it repeats, right? So, but what I can do with this, it would be normally very difficult in order to figure out what type of fraction this actually is. So what I can do, aside from just plugging it into the calculator, because I know that's what you want to do to begin with, okay, I'm going to multiply both of these sides by 10. Now, when I do this, what this does is it actually moves the decimal on the right-hand side of my equation. So I get 10n equals 5.555, still repeating, okay? The next thing I want to do is I want to subtract this repeating portion. Well, we said that repeating portion was equal to n. So what I want to do is I want to subtract an n from both sides, okay, which is really like saying 0.55555. I want to subtract that, okay? When I do that, I'm left with 9n equals 5. Now I can just divide like normal. So in the end, n equals 5/9. So when I'm writing my repeating decimals as fractions, it's 5 divided by 9. So there are a couple of try it problems out below. I want you to go ahead, pause the video, try them out, and when you're done, we'll come back and we'll go over the answers together. All right, now that you've tried the try it problems on your own, let's go over the answers together. Okay, so the first one that I have is write each fraction or a mixed number as a decimal. So the first one I have is 3/4. You may not have even had to do the division for this one because 3/4 is really simple to use. Think about money. 3/4. What's 3/4 worth? 75 cents. If you had to do the division, that's completely fine. You can still work out the problem and get to 0.75. But for A, I get 0.75. Okay? For letter B, I have -3 and 1/11. This one probably needs to do the division for. So again, we're going to forget that there's a negative sign there. I have 3 and 1/11. I'm going to change that from a mixed number into an improper fraction. 11 times 3 is 33, plus 1 is 34. So I have 34 over 11. Okay? When I divide this, I'm going to get 3.09 repeated. Okay? And because it's negative, I remember to bring that negative sign. Okay? So again, if I were to do this out, 11 goes into 34 3 times. Okay? And this is actually going to repeat. And it's over the 0 and the 9. Notice, though, you can actually see this repeating pattern. If you were to continue it out. Notice that it's the 0 and the 9 repeating. So make sure you draw that bar over both the 0 and the 9. All right, for letter C, I have -2/9. So again, for right now, we're going to forget the negative. Okay? So I'm going to go ahead and set this up. 9 can't go into 2. So I add a decimal and a 0. 9 can go into 20. It goes in twice. You get 18. Subtract. Bring down the 0. You can start seeing the repeating pattern. So it's going to be -0.2 repeating. Notice also that I'm also showing all of my work. Make sure that you're showing your work because even if you make a mistake, you still show your work, you'll probably get points for it. Really good for the tests. Okay? All right, letter D was 4 and 13/25. Okay, so again, I want to change this from a mixed number into an improper fraction. But there's another way to actually do this. Okay, I can notice that 25 is something I can easily make into 100. So if I do that, I take 13/25. I want to get it to 100, so I multiply both the numerator and denominator by 4. 13 times 4 gives me 52. So now I have 4 and 52 100ths. Okay? This I can just write as a decimal. So I get 4.52. Alright, now for letter E. Okay. In a recent season, NASCAR driver Jimmy Johnson won 6 of the 36 total races held. To the nearest 1,000, find the part of races he won. So he won 6 out of 36 races. So again, I can rewrite this. Okay. 36 doesn't go into 6, but it does go into 60. It goes in 1 time. Okay. 36 goes into 246 times, and this is just going to keep repeating. So he won 0.16 repeating. Okay, and I wanted you to write to the nearest thousandths. That's tenths, hundredths. So this is actually like this. So this is your thousandths place. So in real life, you would write it as 0.167. All right, letter F says write each decimal as a fraction or mixed number. Okay. Again, I'm going to ignore the negative sign. So I have 14 over, and there's 1, 2, so that means 2 zeros. I can simplify by dividing both of these by 2, so I get 7 over 50, and there was negative sign, so negative 7/50. Can't simplify it any further than that. Letter G was 0.27 repeating. Okay, so same type of thing. So n equals 0.2727 repeat. I'm going to multiply both sides by 10. Multiply both sides by 100 because there's 2 things that I want to do. Okay. Subtract both of these by 1n, which gives me 99n equals 27. Divide by 99. So n is 27 over 99. So this was for F, and this was for G. I can then simplify this, dividing them both by 9, and it will give me 3/11. So that is the end of lesson 1.